I'm going to go through a little bit about using Yubikeys and PIV, which is an interface they speak, to authenticate to stuff. In particular, Manta, Triton, and SSH, and a few other things like that. So I figured I would kind of just go through it from scratch. So I have here a brand new, fresh out of the box Yubikey, which is a Yubikey 4. I'm gonna plug it in, and we're gonna run through setting it up. So one of the tools I'm going to be using, or all the tools I'm going to be using really, are from this repository, which is a bunch of stuff which is actually abstracted from the RFD77 work. But this is basically some tools and PIV agent, which can talk to the YubiKey, which you can use for all this stuff. So first thing I'm going to do is I'm going to do PIV tool list. You notice it's detected there's a new YubiKey installed. It's not initialized. And so we're going to set it up. This takes a little bit. All right, so you see it got to this step and it's asking me to touch the button, which is flashing. Touch it. All right, now I've got to set a pin. All right, and now what we have is a YubiKey that's set up. And what set up means in this case is it's basically gone and generated some keys on it. So the PIV feature is basically a standard for storing keys on a smart card. And the YubiKey is actually pretending to be a smart card for various historical reasons. But it's convenient because it basically gives us a bunch of slots and they're sort of numerically labeled slots in which we can store keys. So in this case, we've generated 4 keys on this thing by default. 2 of which are intended for general authentication purposes, basically, and 2 of which have special purposes. The idea of the slot actually in the PIV spec kind of implies some of the function of that key. So in PIV, the 9E slot, for example, is actually reserved for the purpose of authenticating the card itself or the device. So that's what we will end up using it for. And the 9D key is reserved for managing encryption keys, like encryption at rest and that kind of stuff. 9A is for general authentication, and 9C is for digital signature. So basically, the standard way to set them up, I think, that's best for general like Manta, Triton, SSH use, is to put an ECDSA key in 9A and an RSA key in 9C, and then that way, if you're trying to auth something that doesn't support ECDSA, you can use that one. So how do we use it? So basically what I'm going to do is I'm going to start the PIV agent up. And now I have a shell which has got an SSH agent, which has all of those keys in it. And if I want to say SSH to something using, SSH to something using, say, this key, all right, I'll just add that to authorized keys on localhost. Right. Then I can now SSH to localhost with that key, and it auths. It's pretty straightforward. However, if I go and try to use one of those other keys, so let's say we use that 9A key, right, put that in my host here. So now we've got an error. It says no PIN has been supplied to the agent. Try SSH add-x, signing failed. So what that's telling us is something about how PIV works, which is basically PIV requires certain slots to have a PIN entered before you can sign with them. And if we look at the slots, the defaults are that 9E, because it's meant to authenticate the card itself, never requires a PIN. And 9A and 9C both require PINs. And 9D we set up to require both a PIN and also a touch on the button on the YubiKey. And so what we can do is if we now supply that PIN by using SSH add-x, which is just a standard command. Oops, I fucked that up. And now I SSH to localhost, it authenticates. And you'll notice one of the things that this is able to do as well is if I unplug this YubiKey and try to SSH again. It's obviously going to spit some errors, but it's also now at this point decided to forget that pin. So if I try to SSH again, it says, no, you need that pin back in again. So this is convenient because it means that the pin doesn't stick around in memory after you've left the building, basically, even if you forget to deliberately drop it when you leave. So this kind of gives you a little bit of a almost two-factor auth if you're using one of these keys, because we know that that key is on the YubiKey and you have to supply the pin to use it. And that means that you're kind of given two factors because you've got something you have, which is the YubiKey, and something you know, which is the pin. And the YubiKey itself and the PIV spec won't let you read out those keys in any way. So like these keys that have been generated in here, you can get their public keys easily, but their private keys are stored by the token and it won't give them up. It won't tell you what they are. So that's sort of the basics of it. So now what I might do is I might demonstrate quickly using some of these with Triton itself. So I'm going to use our 9A key to auth to Triton. So I'll take our 9A key, which is this one. I'm just going to chuck it on call. All right. So if I go get test user here, an SSH key. All right. So I've now added it to test user there. Now, if I set my environment up for call, I need to change what my key ID is to match. So which one's 9A? This one. Oop. Once again, we forgot to add the pin. Oh. What's happened there? Oh. I bet. Yeah. Wrong count. My use alias doesn't work properly. And there you go. So we've just authenticated to Triton, and we can also authenticate to Manta. Ta-da. And you can do all the usual stuff, like signing a path, and you can see it signed it as an ECDSH I256 with that key. And it basically all works the same. And you can also go and use mlogin and all of those things. And you've got the benefit that your key is stored on one of these, can't leave it very easily, and you can take it with you. So to demonstrate that a little bit more as well, what I'm going to do is if I SSH to, for example, my build zone, which is called build poop, currently doesn't recognize this key that I'm using. So what I'm actually going to do is add it. Copy it out of here, hey? All right, build poop. And you'll notice I've got everything set up so that it's already forwarded my agent through to build poop when I SSH to it. That's just in my SSH config. And if you in fact go and look in my, I don't have a tmux open because it rebooted. But if I have tmux open and then like log out, log back in, attach the tmux. Oh, I fucked it up. Anyway, there's meant to be that the thing is still there. And the way that works is meant to be in the tmux config, which seems to be missing, which is probably why it's not working. Anyway, you can clearly tell that I did not test this out very well before doing this demo. I think it might be actually just on this machine. Yeah, here we go. This build host has all the stuff set up. So I'll show you how that works. It's basically just that I have this set env, so there's a defined socket path for the SSH agent, and then in my SSHRC, I simply force that to be a symlink to the actual auth sock that's forwarded through. So it's relatively simple to set up, and then basically you now have seamless use of this as you did before, as if you'd had your keys copied onto all the machines you log into, like your build host, because this way I can just use it to talk to Manta straight from there. But the benefit is, of course, that the build host can't upload things to Manta while I'm away, because if I unplug this like that, it can no longer do anything. So, ta-da. Anyone want to see anything else?
You going to touch on the ZFS stuff?
I can do that if you want. So one of the other tools that I ship in the repo with PIV agent is PIV-ZFS. PIV-ZFS has some interesting stuff, but basically what it does is it uses that 9D key, the one that's set aside for encrypting data, and it uses that to help you encrypt a ZFS pool if you have ZFS encryption enabled. So I can demonstrate that quickly pretty easily. Just do like ZFS create. All right, so it's going to ask me what my primary token should be for unlocking it. I'm going to choose that one we just set up. And I'll call that OK4. Now it's asking me to set up a backup. So the backup is an N out of M thing. So you have to choose like 2 out of 3, something like that. And I have a bunch of smart cards set aside for my backups, so I'm going to add them. I just need to find their keys again. Give me a second. Keys. Oh, where did I put them? There they are. All right, so add a key. That one. Call this K1. All right, add K2. So all these values you can obtain just from like that other token when it's plugged in doing PIV tool list, basically. All right, so I'm going to say out of those 3 that I just told it about, I want 2 of them to be required for backup recovery. I hit dot. That was a lot of effort for it to fail. Let's do that again. And please feel free to like ask questions if I'm going through this too quickly. I really want you guys to like figure out where you want this to go. If you're interested in some aspect of this, or you want to know how some particular thing you're worried about works, if you wanted to use it.
Do you want to go into detail about kind of what the PIV-ZFS stuff is doing in terms of how it is that you're using those keys and such?
Sure. So I can go into the high level picture of it anyway. So basically, it's actually going to be easiest to finish the setup and show you. So I'll do it as root this time, so it actually works. Because it turns out you can't make ZFS file systems as Alex.
These other smart cards aren't Yubikeys or something else? Correct.
These other smart cards are $5 things I got off the internet, which look like this. They're a smart card. I use them for backups only because they're considerably cheaper than buying a bunch of Yubikeys for backups. They're also very easy to hide inside books on the bookshelf.
Are they NFC based? How do you read those?
They can either be NFC or contact based. you can do either. And for contact, you basically just need a USB reader, which you can find on Amazon for about $10. I'll show you one if you want. I have one sitting here in my bag. Look like this. Just a USB interface. Basically, any of these you find on Amazon will work, and you just put the card inside it like so, and it will light up and talk to the card. And they speak exactly the same interface over USB that the Yubikeys do. So everything just works. All right, so now we actually have a ZFS file system. You can see it's there. If I get the encryption property, you can see it's set and it's got AES56 CCM. And if you want to see the actual metadata that we wrote, it's in a property called RFD77 config. If I show you what this JSON comes out as, you can see how this thing works. So what you can see here is it keeps it short to try and fit in the space that's actually available in one of these pool properties or fast properties. But there's a couple of configs in here under the O property for options originally. The first one here is n equals 1, m equals 1. So this is a primary config. It only requires one device, which is that YK4 device, which we set up, which is the one we just configured before. You see it's got its GUID, it's got its 9E public key so that it can authenticate it before it starts talking to it. And then here it has a box. A box is, and I can actually unpack this if you want. Into what this is. You see it starts with a magic number, it's got a version number and a couple other things. But basically what this has in it is a structure which I actually have. Actually show you the structure. There we go. I'll show you what the struct looks like. So there's a version 1 box using a hardware key. You can see it's got in it the GUID and slot number of the key it's using and a bunch of information about it here. But the key thing is that basically what this does is you can see here, this is the ephemeral public key in the box. What it's done is it's generated a random ephemeral public key, and it's done elliptic curve Diffie-Hellman or ECDH between that and the public key of the key that's on the YubiKey. So ECDH basically takes two keys, one of which you have the private and public halves of, and the other one you only have the public half, and creates a shared secret between them. So it takes the shared secret, it hashes it with SHA-512, and then it encrypts the actual data with SHA-20, and that's what is in this data bit at the end. So this is basically a concept called a box, which terminology I borrowed from Daniel Bernstein. And the box can only be opened by someone who has the private half of one of these two keys. And we threw away the private half of this second key, which is the ephemeral one. So the only thing that can open this is a private key, which is on the YubiKey, because that will let it rederive the shared secret and then decrypt this symmetrically encrypted bit here. So this box basically contains the actual key that we give to ZFS. And it can be unlocked by this. These ones, so this second configuration here, which is a 2 out of 3 configuration, each of these boxes contains a Shamir secret sharing share of that key. So this one contains the key itself. These three each contain a piece, and then 2 out of 3 of those pieces have to be combined back together to get back to the original key. And that key is the one that we actually give to ZFS. So I hope that kind of makes sense. We're basically layering a public-private key system on top of the symmetric key system that ZFS uses. And this is the same way that the actual RFD77 encryption works, and also the same format for this property, basically, which is why it's called RFD77 config when it stores it. So if you want, we can actually show, so I'm going to unload the key. It's going to become root for a bit. Oops, I mistyped.
So with this, you have to use special commands to do zpool import or ZFS mount. Is that right? Or, okay,
that's correct. So we're going to unload the key for it, which means we're now back to where we'll be at like startup. And PIV-ZFS has this unlock command. So if we do unlock storage ink test, see it's going to say it's using YK4. And now YK4 has started flashing, because if you remember, we told it that this key has to require confirmation with the touch. And then you also have to supply the pin. And now it's unlocked. Now, if I unload that key again, and I unplug this thing, you get to here. All right, so this got a bit noisy because it printed out some extra errors. Whoops. There we go. That's what I wanted. So it says, attempting to unlock, no PIV tokens on the system match primary config. Do you want to rescan and try again? And we'll say no. And then it says, we're in recovery mode. Which configuration do we want to use? We want to use that one. And now what we have to do is either have 2 out of 3 of these on the system to, and you can do them one at a time to use them, or you can do challenge response mode. Challenge response mode is kind of more interesting. This is how the ZFS recovery works. So what it does is it prints out this challenge and some verification words. And then if that other token, the recovery token or card is remote somewhere, like it's attached to a different system, then that system can use this challenge and the response to it to actually perform this recovery. And somewhere in my bag, oh no, maybe I left them at home. Yeah, left my recovery keys at home. So I don't have enough of them here to actually do this. Sorry, guys.
The old I left my recovery keys at home excuse.
Yeah. I could set up some other keys if you want, if you actually want to see it happen. But basically, the person on the other end does PIV-ZFS respond, and they copy-paste this challenge in, like that. It says failed to find token to match challenge, but on theirs, it will actually spit out different text, which will be like, all right, I'm going to unlock this challenge. Here's the information about it. Please ask them verbally if these verification words match, and then hit yes. When you hit yes, it gives you a response. Paste the response back in here, and it proceeds.
Hey, Alex, there's a question or two in chat, which I'll just relay to you for a second. One was that, was there any PIV using SSH agent available prior to this stuff? So
yes. Before I wrote this thing, you could actually use PIV keys through the SSH agent. So you could do it via the PKCS11 interface after installing a huge pile of libraries from OpenSC. And that interface, unfortunately, because of some limitations in OpenSSH, doesn't support EC keys at all. So that would only show you the RSA key. I unplugged it, didn't I? Plug it back in. Yeah, so it'd only show you that RSA key out of all of these. And you would also have to add it every time, and it's a bit of a pain in the ass to use, and it's got a long chain of dependencies to set it up. The other option for SSH agent use with Yubikeys has been to use the OpenPGP applet, which is also what GPG will talk to. That has some other limitations, and I've also found its like smart card talking to be extremely flaky, unfortunately. Like SCDaemon just spits the dummy all the time. I've tried very hard to make this a lot more robust to being unplugged randomly and coming back up safely and all that kind of stuff. The other thing that this does, which most of those solutions don't, is it uses this 9E key to reauth the thing. So if it gets an interruption in communication to the card, it will actually go and ask it to sign a random value with the 9E key to prove it's still the same card. And this is kind of valuable if you're worried about somebody like plugging in another token that has the same GUID. So an attacker could come around and like program the same GUID into their token and plug it into your machine. And then because you've like saved the pin in the agent like this, you might send the pin to the attacker's token instead of yours. unless you're actually authoring with this 9E key and keeping an eye on it.
The boxing that you did for the RFD77 attribute, was that your creation for this project? Or was that derived from something?
The format is my creation, but I mean, the box format is the box idea is basically stolen from libnacl. You can also use the box on its own, like this. Right? And then I can like, or I just, yeah. And it's once again going to flash at me and ask for the pin, and I'll put that. And there's a box info command as well, which basically shows up that info which we looked at in the hex editor.
Are the OpenZFS folks, have you reached out to them? Have they been interested in making this a more first-class citizen in that world?
So I did kind of mention what I was doing at one point to some of those guys, and they were like, oh yeah, like talk to us more when you've actually like got this in a real system and have proven it out a bit. It's kind of getting there. Like I'm actually using this on my actual desktop all the time. So if you like look at, you can see that I have an actual config here, which is against my YubiKey Neo, which is my personal one I carry around, which is applying to my storage pool on this machine. And my home directories are also under that. But, yeah. So
that's
actually,
all ZFS on Linux, right?
Yeah, it's still ZFS on Linux. And I've actually modified, where is it? No, not there. I actually had to modify, yeah. So if I do, I had to make some small changes here to the init RD hook. Because my home directories are protected like this, I actually have to make it so that in the init ramfs for Linux during boot, it has a copy of PCSCD and the PIV-ZFS tool, and then actually runs it for me. So when I'm actually booting this machine during boot, it will come up and ask for my PIN to unlock my home directory before it mounts it. And there are a couple little changes I had to make to the script, annoyingly, but that's life, I guess.
Sorry. Can I ask a question? Yeah, I guess
You
I
may.
can. Okay.
Please do.
It's part one and part two. Part one is one of the historical reasons the YubiKey presents what it does is because of PKCS 11.
Not really. It's just kind of like everybody is settled on smart cards as like a primary method for storing these kinds of credentials.
Okay.
So the YubiKey presents the CCID interface because it has a secure element chip in it, and the secure element chips are just always designed to fit either in a smart card or inside some USB device.
Okay. And then part two related to PKCS 11. Today I was poking through the source and you have a -P flag for PIV agent. It's like, nope, PKCS 11 right now. Someone, and I'm not saying you, I'm just saying someone would need to write a YubiKey driver for it to plug into the Illumos PKCS 11 that we have today. Is that true?
If you wanted to use it that way, so the reason why I wrote PIV agent is basically because for most users, people don't actually really want the PKCS 11 ecosystem because it's a pain in the ass to manage and set up a lot of the time.
Having written a good chunk of it for ian.ikd, I can attest to that firsthand. And related to that, that's why I was asking, because
right. So this SSH agent interface that's set up here, like the PIV agent thing, it doesn't do anything with PKCS 11 at all.
Okay.
It's just a single binary, and if you look at what it links against, like it's linking against the PCSC light, but other than that, it's all base system libraries. It's not pulling in anything. It doesn't dynamically load anything else. It's actually just talking directly to the smart card.
Okay. I'm the reason I ask is because I'm very, all this stuff you're doing has me thinking, gee, it would be swell if I could type an IkeCert token and list and see the YubiKey there someday, but that's going to require work that's outside your scope. So
yeah, there's no reason we can't do. There's no reason we can't do that in future. It's just not really because this is all abstracted from IFT77, where we're quite happy to just talk directly to the tokens.
Yeah, and again, I'm not asking you to do more. I just wanted to make sure that there wasn't partial work done by accident.
It is kind of libraryified a little bit inside. So like if you look in piv.h in the repository, you'll see the piv related functions and stuff.
Oh yeah.
You can see that like basically the way you use it is you do piv enumerate, piv tokens, you choose the right one, you open a transaction with it, select it, and then you can like read certificates off it.
Make it sign. Yep.
Yeah. Verify a PIN. Auth says here sign and sign with pre-hash data.
Yep.
Or do ECDH, and then there's the box functions and stuff.
Yeah. Oh God, that's another thing ITD doesn't do, but that's not your problem. Okay. Yeah, we have to wait for V2 for that. Okay, thank you.
That's all right. So on the topic of like how the pins and stuff work for PIV, there's 2 pins which the YubiKeys support, which is the pin and the puck. The idea is that the pin is the primary code that you use to authenticate to the token all the time, and it's anywhere from 6 to 8 characters. And the YubiKey will accept any alphanumeric character and a certain selection of symbols to go in that slot. The reason why it's limited to 8 is basically because the PIV spec was designed for numeric pins. It's sort of based on like the SIM card spec for mobile phones, and those pins are the same rules. It's 6 to 8 numeric digits, but the YubiKey relaxes the numeric requirement only. So there's a pin, and then if the pin is blocked, you can reset the pin by supplying the puck, which is just a second pin code basically. It's meant to be like a backup if you somehow end up with the pin blocked. If you max out both the pin and the puck, then all the keys on the token are destroyed. So that's worth keeping in mind. If you use up the maximum attempts on both of those, then all the keys on it are destroyed, and the only way you can get it back is by resetting it completely to factory settings. The other authentication that's there is what's called the admin key. The admin key is what it uses to generate new keys and set up slots and change settings and stuff. It doesn't let you sign data. You always need the PIN to sign data with the key. But the admin key can let you, for example, blow away one of the keys and replace it with a new one. So for that reason, the setup procedure, which we ran at the beginning here, you'll notice actually randomized that admin key. It just set it to a random value and said, like, if you don't intend to make changes to this config in future, then just forget about this value now. And like, if you need to do anything to change this YubiKey in future, just fully reset it or buy a new one.
Anyone have other questions for Alex?
I mean, one thing that some people have brought up is that is performance. These things are considerably slower than signing something on the actual host CPU on most machines. For example, the YubiKey to sign something with ECDSA takes about 70 milliseconds. It is good enough for regular use. Like, I don't find this particularly problematic when I'm dealing with, like, even doing a big M-find to create a Manta job on production. I find the 70 ms per signature is actually fine. It is a bit, you can kind of notice the difference a little bit, but like for interactive use, you don't really notice 70.
The big RSA signs are a lot slower though, right?
Yes. Like an RSA 2048 sign on a YubiKey is about 200 ms. That's quite noticeable. Which is another one of the reasons why generally, like for general purpose auth, I think you should just use the ECDSA keys on these.
I have to ask, does it support 4K RSA? And if so, does it take like a whole second?
So the YubiKey itself, the device supports 4K RSA, but the PIV spec doesn't have an algorithm identifier for 4K RSA. It does have an algorithm identifier for 3K RSA. However, it's considered deprecated, basically because so the PIV spec is actually written by the US government. It's written by NIST. And what it's intended for is for identifying people. So what you'll get if you're part of like a government or military organization that uses PIV, you'll get your ID card, your ID badge, and it will be a PIV card.
Yes.
And it'll have certificates on it, which have been signed by like an organizational CA. And to open doors, your card has to sign a random value to prove that it's your card. And so you don't really want that to take most of a second, because that is way too easy for like contactless interface to have an interruption or noise or something if you're going to sit there for a second talking to it.
Okay, that makes sense.
So they actually took the 3K RSA out of the recommendation in about 2010 and said, look, just use 2K RSA. It's good enough for the purposes of authenticating a user. So yes, the YubiKey does support 4K RSA in other applets, not PIV. It is very slow. A 4K RSA sign on a YubiKey 4 is about 900 milliseconds.
How does this for RFD77 work in production? Is there like a YubiKey per CN, or how are they actually?
Yeah, so I mean, the RFD77 design is kind of separate to this, because these are basically just like, I've taken some of the user tools that are part of RFD77 and made them a little bit more portable so you can run them on Linux and OS X. But the RFD77 design itself is somewhat different. Like, it shares a lot of the code here, but it is actually using a thing called a persistent daemon, basically, that manages the card and does a lot of this stuff, as well as parts of the PIV agent code. But yes, it's going to have a YubiKey in every machine, which is going to be in either an internal USB port or like one of the really miniature ones hanging out the back so that you can't remove it easily. And yeah, so it'll use a very similar approach to PIV ZFS. It'll use the same storage format for it, at least, for the information in the pool. And it'll be basically the same deal, where like there's a recovery process if you lose the primary token, where you do 2 out of 3 or whatever.
So does an operator have to unlock the Z pool then, or how is it actually getting the pin?
So the pin in the RFD77 case is managed by the system. And what that means is that for a head node, it either gets it off its USB key or off a pool property, or an operator supplies it on the console at startup. For an ordinary CN, it gets its pin from the head node. So the head node actually keeps track of the pins for all of the CNs in the system. And the CNs actually use their 9E key, which doesn't require a pin, to sign a challenge from the head node to prove that they're there. And then the head node sends them the pin, and they can use that to open the token.
Are there any thoughts about how this might work if a customer has a requirement for them being able to ensure their data is not recoverable by the system?
What do you mean, not recoverable?
So normally for full disk encryption, I'd expect that for full disk encryption from the standpoint of guest VM, that they would be able to throw away the key, and then the data is forever gone. It seems actually
so
the problem is per data set, right?
Right. So the disk encryption keys are different for every node.
Okay.
Because every node has a YubiKey and is storing it like that. But these are not, so we don't have really the capability today to implement a per customer encryption key.
Okay, so this would be
VM. It's per CN in the RFD77 design.
Okay,
It's basically designed to protect against improper disk disposal. Like if a disk from a production CN is thrown out without being fully erased, it helps deal with that. It also helps deal with somebody going into the cage and walking out with the machine.
Right.
Because that machine won't have the information on it. It needs to decrypt the disks. Unless it's a head node, and then even then you can use the option where the operator has to put in the pin for head nodes. So as far as the use case of a customer wanting to feel like they can erase their data by throwing away an encryption key, that's always kind of a lie in the cloud. If you look at what Amazon and others do, really you still have to trust them not to sniff that key out in the middle and keep a copy of it. You have to trust them to not be storing it improperly, because you don't really necessarily have outside attestation that this storage device that they're giving you is secure, except for their word.
Right. Okay.
Okay, everyone, I want to say we're kind of running a little bit over, but I just wanted to say thank you, Alex, for the presentation. If folks have additional questions, obviously feel free just to shoot them towards Alex or ask in MIB. And we'll see everyone next week with Dave Eddy on VM Info D.
Thanks, Alex, and thanks